Hey everyone, good morning, good afternoon, and good evening to all of us who all are joining us globally. I am Partharu, Event Program Manager for Microsoft Reactor, and I welcome you all to our show Tech Espresso. But before we begin, let's go through our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in the way you all engage. Yes, obviously, we do encourage you all to participate. Please drop all your questions in the chat section and we get all your questions from there. Now, I'd like to bring in speaker for today's session. That's Vinayak. Hey, hi Vinayak. Morning to
Hi,
you.
Shepard. Hi, how are you?
I am good.
Cool.
So,
Go on, please.
I was just about to ask, like, what do we have today at Tech Espresso?
Hi, my name is Vinayak Hegde and I'm the CTO in residence at Microsoft for Startups. And today we are going to do an introduction to OpenAI and Azure OpenAI Service. And we are going to do a bunch of demos and see how to start using OpenAI in different applications and get familiar with it. So this is mostly going to be like a level 100, level 200 kind of session where we actually play around with the OpenAI and Azure OpenAI Service.
Cool, Vinayak. The floor is all yours. And please drop all your questions in the chat section and we'll pick it up from there.
Cool. So let's get started. We have a lot to cover today, and I said I'll be talking about introduction to OpenAI and Azure OpenAI Service. So let me start off with the evolution of artificial intelligence, right? I mean artificial intelligence has been around for a long time, and then it has gone through several kind of winters, as you say, right? Where there were a lot of advances, and then nothing happened for a while. Then there were advances, and nothing happened for a while. And it seems as we have progressed over the years, first we had artificial intelligence, and then a subset of machine learning, and also the advance in both the GPUs and CPUs made machine learning viable, and we could start using a subset of AI to enable machines to learn from existing data, and and also improve upon that data to make decisions and predictions, right? So if we go further down, then I think the two biggest advances have happened in the last few years, like last 4 5 years, if I were to say. One first was obviously the machine learning technique of deep learning, in which layers of neural networks were used to process data and make decisions. And I think the most one of the biggest breakthroughs was also in terms of the image classification and recognition, and that kind of spawned into various technologies. And now we are looking at generative AI, where it even though as a technologist, I've seen bunch of technology. I think it seems in some sense like magic, where you can basically give a text description, and the generative AI can generate not only text but also visual and auditory content based on prompts or existing data that we give it to. So this fundamentally differs. The generative AI fundamentally differs from how we have done traditional a model development, right? So if you were to look at the traditional model development, there was high cost, and that amount of time it would take to deploy models was slow, and each service had to be trained separately. So the traditional approach of AI model development involves training a model on a very specific data set, and with a specific task in mind, right? As you can see on the screen, we had tasks like classification, object detection, object tracking, action recognition, entity recognition, topic detection, and sentiment analysis, right? And each of these had like individual models, which was fine tuned with like training data, which was either tagged or there was a deep learning used. Um, and always you had to have a specifically trained data which can be used for training, and then that actually sometimes became like a bottleneck to be able to train and curate that data, because each of those data was segmented separately. But what has happened in the last few years is we have come up with the idea of foundation models, right? So What foundation models are different is that you have data, your text, your speech, structured data, 3D signals. You take all of these data and use that to train the model. So it is based on an famous paper is what it's called as attention is all you need, and um, that from that came the transformer model, um, and then that can be adapted to a variety of tasks. The same model that is can be adapted to a variety of tasks. You can use it for question answer, sentiment analysis, information extraction, image captioning, and following instructions. Right. So the future of AI models that are flexible, reusable, and that can be applied to just about any domain or industry. So foundational models are at the heart of many of the latest breakthroughs that you've seen, and I think the breakthroughs have been coming thick and fast that just sometimes even hard to keep up with them, right? And Yeah, so foundation models use self supervised learning and transfer learning to apply the information learned from one situation and in the training data to other situation or task. So training these models can be like complex and resource intensive. These are typically large, and if you see some of the later models, some many of these models do not actually fit into the available memory that is available in GB. So you have to be very creative and able to train these models as well. So let's look at some of the models um, and how they have evolved over time. So you had the BERT, which was a widely used language model, which was released in 2018. That marked the arrival of the first NLP transformer model. It is an auto-encoding model focused on the encoding part of the transformer, and it has about 340 million parameters. And the parameters are used to calculate the size of these models and can be thought as connections between neurons in the brain. Um, going forward, we had the Turing NLG model, which was released by Microsoft. It was the largest ever model that was published at the time. It had about 17 billion parameters, and it prompted the launch of AI at scale within Microsoft, a dedicated division to expanding the boundaries of language understanding and building the best-in-class models for use by Microsoft and through Azure. And we'll talk as we go ahead. We'll talk about how these models are available in Azure. And it used parallel computation and distributed learning to be able to train this model. And then there were technologies such as deep speed and zero that were used while training this class of models called as Turing NLG, TURL, V5, or Megatron. So how does it relate to what we have today, right? I think GPT-3 came out and it was it kind of changed the world, and then we had Chat GPT, and then recently I think the last couple of weeks we have GPT-4 as well, and we'll talk about that. But just to give you a sense, how big these models are. I think we talked about BERT, which was still large with 340 million parameters, but GPT-3 has approximately 175 billion parameters. And although there is a clear performance gain from increasing the model capacity, it is not clear what is really going on under the hood. Especially, it remains a question of whether the model has learned to do reasoning or it simply memorizes the training models in a more intelligent way. In contrast, the human brain, which has approximately 86 billion neurons, uh, um, um, with an average 7,000 synapses per neuron. So comparing apples to orange in some sense, but the human brain has about 60 trillion parameters, about 300x more parameters than GPT-3. Again, it's not like exactly point to point, but it was very expensive to train GPT-3, right? But I think GPT-3 in some sense demonstrated what is possible with large language models without any fine tuning, and being able to do the task. So essentially, what these large language models do is they look at all the training data, and once a model is trained, they predict what the next token should be, and essentially that is at the heart of these large language kind of models. Um, so let's look at the next one in this series. And we had, as I said, in after GPT-3, we had the Megatron Turing NLG. which was jointly trained by Microsoft and NVIDIA. It had 530 billion model, and I think the relative size of the models actually shows you, how large they were. And as I said, it is no longer possible to fit all of the parameters of this model in the memory of even the largest GPU, right? So the large number of computer operations require a result in an unrealistic long training time. So a little bit about the I would say the different kind of news items that you would have seen, like when ChatGPT took the world by storm, which was like basically GPT 3.5, which was basically tuned GPT model, which was basically tuned for dialogue, right? Most of, and as we'll see in the demos as well, most of the earlier models you actually gave it a prompt and it generated some text. But what was different about ChatGPT is that you could actually converse with it, and you could actually layer on more and more context, and actually it would refine the output, which was, it would in some sense, for a lack of better word, it would remember what was the earlier context and actually change its output in a as it got new prompts. So a little bit about OpenAI. OpenAI is a research company that aims to develop and promote AI in a friendly way, and has hopefully benefited humanity in a positive way. And it has made significant breakthroughs in the field of AI, particularly the areas of natural language processing and machine learnings. And as you can see from the news articles, it has received quite rightly, a large number of, I would say, a large number of uh, positive media coverage as well. So Microsoft and OpenAI have kind of come together to basically provide these foundational models. And as you can see at the bottom of the screen, there are multiple models that are available. There's obviously GPT-3, which can generate and understand text. There's Codex, which can generate and understand code, and it is what powers GitHub CoPilot as well, if you have used it, and we'll talk a little bit about that. Dolly, again, generates images from text prompts, and ChatGPT, what we just talked about, is optimized for conversational responses. And finally, GPT-4, which just recently came out, it can generate and understand both image and text, and is one of the multimodal models which you can not only be able to chat with, but also it can, it can, as I said, not only take and be trained on different kinds of input, but it can also output different kinds of things. So there are, as part of this partnership, there are, OpenAI in some sense develops a kind of technology, and Microsoft actually provides, in some that to some extent, I would say, the training data, the infrastructure on which it is trained, but also takes these services and is able to commercialize them, and add a responsible AI kind of layer, so that this can be actually incorporated in different apps, right? And that is what I think is Microsoft's contribution to this partnership. So a little bit deeper into each of these prompts and what they can do. So let's say GPT-3, right? You write a small prompt. Say, for example, you can ask it to write a tagline for an ice cream shop, and it gives a response. One of the responses it can give is, "We serve up smiles with every scoop," and it sounds fascinating, right? It's a good tagline um, for an ice cream shop. Or you can ask it, if you're working with code, and you have the Codex model, uh, which is tuned for code. So you can basically um, tell it, how your columns look and how your table structures look, and then basically you asked it, how do you write a SQL query for all the customers in Texas with a certain name, which is like Jane, and it generates a query. Or we talked about image generation as well, right? So in the prompt, you can write a white Siamese cat, and then you can see the image on screen, which was uh, one of the responses. So as I said, GPT-3 is for text completions, and it is a set of models that can understand and generate natural language. It is a series of models, and we'll go a little deeper, a little bit ahead. Codex is a set of models that can understand and generate code. So it is including translating natural language to code and back. And it is specifically tuned on both natural language and code, which is what is different from GPT-3. And Dolly is a set of models that can generate and manipulate images based on the images based on natural language prompts. So let's talk about the latest kid on the block, which is OpenAI GPT-3 now. So GPT-3 is the latest milestone in OpenAI's effort to scaling up deep learning. It's a large multimodal model. What it means is it can accept image and text inputs and emit text inputs. While less capable than humans in many real-world scenarios, it exhibits a human-level performance on various professional academic benchmarks. So, for example, it passed a simulated bar exam with a score about top 10% of test takers, right? Just to give you a contrast, GPT-3 scores was around in the bottom 10%. So you can see the improvement that has happened, like in a couple of iterations as well. So it wasn't easy. OpenAI spent about 6 months iteratively aligning GPT-4 using lessons from its adversarial testing program as well as ChatGPT, resulting in better quality results on factuality, steerability, and refusing to go outside the guardrails. And I think if you have been following the news, GPT-4 can also interact with the external world using plugins. And plugins are tools that are specifically designed for language models as a core principle and help ChatGPT access up-to-date information, run computation, or use third-party services, right? So language models are really good at understanding and interpreting human language, but they may not have the latest data, right? For example, if you want to, if you see the link at the bottom, I think this was one of the integrations that was done with uh, uh, Wolfram Alpha, and what you can do things like find out what is the distance in kilometers or miles between say Chicago and say Kyoto, or you can ask it who are the world's best or who are the world's largest producers of beef, and then you can draw a map of those countries and color them as a heat map. So you can do these very funky things using chat, and then what ChatGPT does is it is able to take that data and translate it into something that Wolfram Alpha can understand, and take whatever the data is generated from Wolfram Alpha and understand in a language, right? What is so significantly different as the models become bigger and the training data set larger is there are emergent properties of LLMs, right? And this kind of GIF actually animates, as the if you look at different branches of knowledge as different things. What happens tends to happen is as you use more different kinds of data, unlike like the earlier model where GPT-3 was trained mostly on data, and then you had Codex which was on code. But when you kind of combine both of them, I think that is when it kind of displays emergent properties. And not only does the model get better at doing natural language processing, but also gets better at things like question answering, arithmetic, common sense reasoning, pattern recognition, joke explanation. So the model actually starts becoming better and better. We don't know exactly why this happens, and this is an area of ongoing research, but this is something that has been kind of seen over a period of time. Cool. So let's move on to, now that we have talked about the language models, let's go to more practical applications, see where it kind of fits in. So you have the Azure AI, and these are like the different kind of services that are there, pre-existing for business users, application platforms, and the scenario-based services like this cognitive search, form recognizer, video indexer, immersive reader, and a different kind of customizable model for vision, for speech, for language, for decision, and then there's OpenAI service. And if you want to kind of deploy your own models, and Azure machine learning actually allows you to build your own models, so you have that option as well. So Azure AI is a collection of artificial intelligence services as that are offered by Microsoft as part of its Azure cloud platform, and the services are designed to make it easy for developers and organizations to add AI capabilities to their applications without the need for extensive expertise in AI. And I said there, like, three or four main categories. One is Azure Cognitive Services, which is the fourth layer from the top. And then you have the applied AI services, which is like in the middle, which is combination of different services. And OpenAI actually kind of fits into the customizable AI models, which combines multiple different capabilities, as we have seen earlier. And we shall see also at how it is integrated to platform layer and application layer as we go further in this presentation. Cool. So let's talk a little bit about the Azure OpenAI service. The Azure OpenAI service is deployed within your Azure subscription, secured by you, accessed only by you, and tied to your data set and applications. It is a large pre-trained AI model to unlock new scenarios, and we'll talk about those scenarios in a bit. The custom AI models are fine-tuned with your data and hyperparameters, and you have built-in AI to detect and mitigate harmful use. So that comes inbuilt, and this is the responsible AI part that I talked about. And you have enterprise grade security with role based access control and private networks, right? So only authorized people or people who need to have access to those models will be able to interact with those models, either or train those models or fine tune those models, depending on what is the use case, right? So you have so these are, in some sense, I would do guardrail in terms of security, in terms of harm mitigation, that are built in the Azure Open AI service. And if you see on the left, these are all the models that we talked about that are available on the Azure Open AI service. Um, the Azure Open service provides a number of different features, a wide range of pre-trained AI models. Developers can access and use pre-trained AI models developed by OpenAI, such as GPT-3, Dolly, ChatGPT, Codex, and that tools fine-tuning models. Developers can fine-tune pre-trained models to adapt them to specific use cases, such as natural language understanding or computer vision. You interact with this APIs to this model through a variety of APIs. So the service provides a simple, consistent API for interacting with the model. So you can actually interact with the models in a very easy way. And in terms of scalability and reliability, the service is built on Azure, so it can scale and handle large amounts of traffic as well. And I also talked about security and compliance, where it's RBAC, access control, role-based access control, or limiting access within a private network, or using harm detection, right? Let's look at a very specific example. We talked about this in a generic way, but like this is how OpenAI is used along with GitHub. So many of you might have used GitHub CoPilot. So at the left you have the OpenAI Codex model, which has used public code and text on the internet to train, and then you have the GitHub Copilot service. And what it does is the private code provides editor context, and GitHub provides suggestions, and then you reject or ask to refine the suggestion, and this kind of continues until you are able to get code that you want, and then you can actually compile it, change it, edit it. So you're always in control. But what it does is it acts as a co-pilot or a friend to be able to be able to code faster, right? So just to give a set of statistics, um, um, according to GitHub, Copilot is now handling up to 40% of coding among programmers. Or put another way to think about it, for every 100 lines of code, about 40 are being written by AI, which is amazing. And this results in a total project time which is cut by up to 55%. And again, as I said, we are at the beginning of this new evolution or revolution of computing, and even with that, we are able to reduce the total time by half, which is amazing. And this is, as I said, first iteration on the model, and it has been in production for less than a year, or just about a year right now. So another example is Dolly, and as I said, Dolly, you can see the prompts on the top and the pictures that are generated at the bottom of the screen. So an astronaut riding a horse in photorealistic style. which is fantastical, right? I mean, and it's able to do that. Or teddy bear working on new AI research on the moon in 1980. So you can see the computers are a little old, and you have those specific data drives or floppy drives as well with the CRT monitors, unlike the flat screen that we are slowly getting used to now. And you can see on the right there, which is like a bowl of soup, which looks like a monster knitted out of wool, and it's like a really funny picture. And so you've seen text, you've seen images, and now I'll just quickly show you a demo of video. So you can see that there is the prompt on the left. So this is a model called Numa or Infinity, and it's again a multimodal model announced at Microsoft Research. And this model can generate high quality images just from text, and even can predict the next frame to generate lifelike videos. So I'll just quickly show you the videos as they're generated on the left. So you can see your cloudy morning on the beach, and the tide coming in, and it's actually generated the waves very beautifully, right? With the water receding away from the beach and the waves also crashing onto the beach. Or in the mountain with clouds, you can almost see that it generates almost like a drone footage as the peak of summit of the mountain comes into focus. So let's move on to now we've seen some demos. Let's move on to the Azure OpenAI considerations. So when to use Azure OpenAI? So I think this is a good checklist to do. You need a general purpose model that can handle multiple tasks. You need to generate human-like content while preserving data privacy and security. Examples could be abstractive summation, content writing, paraphrasing code. You need basically rapid prototyping, quick time to market, especially useful for startups because uh, you know earlier I think you had to kind of build a model, first get the training data, validate the data. Once you validate data, choose the algorithms. Then you had to train the model, and that used to take time. Or you had to use auto ML in some cases to be able to figure out what is the best kind of features, what is the best kind of algorithm ensemble to actually train. But here you're kind of bypassing all of that, right? So you can quickly, rapidly prototype and see what kind of works. And if that works, either continue using that model, or even you can actually build your own in-house model if you feel that you can probably do a better job in very some domain specific things. Um, and you can use the model with little or no training, right? So it uses what is known as few shot or zero shot learning in most cases. So you don't have to train the model as well. And you can also explore what it gives you. It gives you the freedom to explore solution or use cases that have been kind of described previously. And again, like you can use each of these in conjunction with vision, speech, language, decision, so on. So when we talk about OpenAI, right, most people are very familiar with ChatGPT, but there are actually different models, and each of them do slightly different things. There's GPT 3.5, which is ChatGPT. So it takes the prompt, which is text and code, and it can be used for almost anything. Dolly, as we saw, can be used for website layouts, product variations. This Whisper, which can convert audio to text, so you can do podcast or video transcriptions. You have you have Codex, which is uh, you know uh, can generate code, and then your moderation, which can do live stream content moderation. Another way to look at the model, especially GPT-3 models, is something like this, right? So you have the Ada, Babbage, Curie, and Da Vinci, and you can see on the left-hand side, tells you the amount of inferencing time that is there, and also on the lower bottom of your screen, it shows you the capability, right? So as you go from left to right, I think the capability of the model increases, but also the inferencing time increases, right? And then the Codex model, which is the Cushman Codex and the Da Vinci Codex model, which have the same kind of capability. And in this slide, you will actually see that what could each of those be, right? So I think I would suggest that maybe I'll spend a little bit of time on this slide, because this is like important, because you need to, in some sense, choose the right model And also, I think the pricing is also tied to tokens, and we'll talk about a little about the pricing later on. But as the inferencing time increases, as the capability increases, the cost of the model also increases, right? So figure out what is your use case. So if your use case is like simple classification, parsing and formatting text, ADA actually is fairly capable at doing that. If you want to do like semantic search ranking, moderately complex, classification, then Babbage works. If you want to have maybe slightly more nuanced classification, or you want to be able to answer questions, then Curie is good. And if you want to do summarizing or generate creative content, then you have the DaVinci model, which is the most capable of that. And similarly, it is for the Codex model as well. Cool. So roughly, so we've talked about tokens, right? So tokens are about about roughly each token is about 4 characters roughly, and you'll see that tokens are used for both generating the output of the model, as well as it is also used in the pricing of the model. So the knowing about tokens is actually very important. And you can see the DaVinci is like the most capable GPT model. It can do any task that other models can do, often with higher quality, longer output, and better instruction following. So if you have complex intent, cause and effect, summarization for the audience, this is the model absolutely go for. Curie is also very capable, but faster and lower cost than DaVinci. So if you're looking at language translation, or complex classification, sentiment analysis, or text summarization, this could be useful. And finally, you have Babbage and Ada, which are also lower cost and can do things like parsing text, classification, address correction, or address detection, and finding keywords. So just to give an example, Curie can perform on many of the same tasks as DaVinci, but it's much faster, and it can do it for almost 1/10 the cost, right? So that is like, just to give one example, uh, um, uh, about the cost. Another thing to talk about is, um, when you're experimenting, when you're exploring, what model to use. Our suggestion is that you maybe start with DaVinci and experiment, since it gives the best result. And once you've got things that are working, see if your a lower model can actually work for you, and see how the result differ. If you feel that you're getting good enough results, then you can actually in some sense go with the lower latency, lower cost model as well. And you can also fine tune these models a little bit, so that they can perform a specific task as well. So if there were maybe like one or two takeaways I would go from a talk, is differently to understand what is the difference between the models and how to use them. Um, so again, like when you look at GPT-3 and you want to experiment and fine tune, you can iterate on ideas with either by changing the prompts, adding to the prompts, or and seeing how the response changes. Or if you're kind of helping it, if you want to do few shot learning, then you can actually give it a few, maybe like 2 or 3 or maybe 4 examples, to actually be able to understand what you want the model to do, right? Which is very different from what the models that we have do. They were not very interactive, right? And you had to kind of go through the training. But here you can actually train them on the fly by few shot learning, and be able to change the response accordingly. And then optimize and accuracy and latency to validate proof of concept, right? I talked about fine tuning, and as well as by changing the parameters, or changing the context, or in some cases trying a lower level model, and see if it gives a very similar kind of output, or acceptable output for you. And this is how you can iterate with different kind of models. So as you can see, the way you work is fundamentally different from how you use other models. So if you look in terms of capabilities, these are some of the tasks that you can do. You can write essay outlines, maybe complete um, uh, co- uh, I would say college applications, do some amount of subject research. For example, let's say I want to do a talk on maybe cybersecurity, right? And I have like 4 or 5 points in mind. I can use it for figuring out, okay, what else should I be covering, and then look at the output and say, hey, does this look okay? Maybe this should be not. So you are always in control, but actually it will help you kind of think about different things. You obviously can do language translation. You can use it as a virtual assistant. You can use it for poem creation, and hopefully we'll be able to do a demo of the poem creation as well. And we'll talk about each of these. So there are possibilities for limitless generation with a few lines of input. So I won't be going deep into prompt engineering because that itself is like a maybe like a 2 hour talk, because it involves a lot of things. But I quickly want to mention a few things about prompt. So I talked about zero shot, right? In zero shot, the input prompt does not provide any examples of the task to be achieved, but only a description of the goals of what is to be achieved, and the model goes back and generates a text for you. Or you could provide a single example of what you want the task to achieve, and it would actually output in that particular format, hopefully. And a few shots is like you give multiple examples, as we saw earlier, and then input provides that multiple examples, and the output actually automatically confirms. So we'll see an example of this later in the talk. And again, the important thing to know is prompt is still written and spoken grammar. So punctuation, parts of speech, capitalization, abbreviation, and impact, all of these impact what's happening a lot. So think hard about what you want to achieve. The clarity of input and accurate description is key to getting the desired results. Knowing domain expertise or knowing a subject and use case before designing a prompt for it matters. For example, if you're doing legal research, or if you're doing medicine research, or slightly more specialized research, you need to know a little bit domain, or work with a domain expert who can actually help you figure out the best prompt. And specialized topics require more specialized prompts. And again, like, the best prompts are the one that in some sense are a compressed form of expressiveness, right? So it's playing like a game of charade to figure out what kind of prompt will get the right kind of output. Cool. So enough of talk, and let's quickly jump into demos. So let me quickly bring up the screen. Meanwhile, any questions? Let me just quickly check if there are any questions while I'm setting up the demo. Okay, uh, we have some questions. I think which model can help in cybersecurity is asked by Sunny Bhatia. And actually, you can use the actually, depending on what you're using, right? If you're doing, for example, log processing, maybe tokenization and log figuring out what is happening in the logs, the ADA model could be useful. If you are looking at log output and you want to summarize what is happening, like, is there an attack, or are there a lot of requests coming from certain IPs? If you want some kind of analysis, then maybe you can use DaVinci to actually figure out, do some summarization of the logs. So depending on what is the use case, you can use different kinds of model, right? So simple log parsing, use ADA. But if you want higher level kind of summarization to figure out different kinds of sources and correlate them, then maybe use something like DaVinci, and then we can experiment and see what can be used where. How can this be modeled help for banking industry, which is asked by Gokulnath Krishnamurthy. So again, like, there are multiple use cases that you can use in banks. For example, um, uh, if there is, like, say, an insurance claim, and you want to figure out what are the parts of the insurance claim, right? So this can act as a way to kind of summarize in a human format. Like, you could have a form, and it could actually be able to find. Otherwise, you can combine it with the cognitive search, and then figure out um, which kind of documents are needed, or what do the documents say in the banking industry or the insurance industry. At the same time, if you're interacting with customers, this can help them actually as a chatbot as well, right? To build chatbots that can do turn by turn kind of answering. Those kind of things also can be used. So again, like, it can be used for internal use, it can be used for evaluating maybe applications, it can be used for evaluating claims, in a whole bunch of whole bunch of use cases. So how can IADO tabs actually ask how can we apply these AI models in trade finance, import and export? I will be covering something similar, so I won't answer this question now, but I'll reference this when I play the demo, recorded demo a little later in the presentation. So with that, let's maybe start off with the demos. So here I am in ChatGPT, and I am going to start a new. Okay, I can't see my screen behind, but let me try this. So let me type, say, create a. Let me create an Azure AI virtual assistant. So let me try that first. So so what I'll do is I will um, yeah, what I'll do is I will ask it to create a prompt for a virtual Azure um, assistant that can help me uh, make more productive on Azure. So let's see what it generates. Oopsie, I think the demo guards are not with me, so let's try again. Create a prompt for Azure AI assistant that will make me more productive on Azure. Let's try. Okay, this isn't working for some reason. Let me try reloading. But anyway, so let me clear this and I have a prepared prompt from before, so let's try using that. So it gave me a prompt, something like this when I prepared the demo. And I'm just pasting it in the prompt, and then I can ask it questions like, can you give me, can you tell me how to create VM on Azure, and then I hit submit. And it what it's doing now, it's creating the steps that I need for creating a VM, and basically I can keep on asking it, different kinds of messages. So let me ask it another question. Say I'm I want let's also increase maybe the number of tokens that generate, because this is likely to be a larger answer. So do you have any advice on what Azure data store or database I should use? I have an e-commerce application with a need for transactions and analytics, and let's see what it recommends. So it's recommending Azure SQL database, Azure Cosmos DB, and it's telling me what are the pros and cons of both. And it can create. But let me say also, can you also suggest some open source alternatives? and see what it comes up with. So it's suggesting MySQL to me, Postgres to me, MongoDB if you have a NoSQL database, Apache Cassandra as well, and yeah, yeah. So it has generated that text, and it also tells me that you might require additional resources, expertise to set up and maintain compared to the fully managed services by Azure, right? So it's actually telling me, not just giving me the alternatives, but it's also telling me what are the pros and cons of each, which is fantastic, right? So now what I have used it to, give an answer to me as well. So now let me kind of reset this. Now we're going to an example. Let's try to do something more fun. Um, I can ask it maybe. Let me ask it um, to generate some poetry, and let's see. We can, if we can have some fun with it. So I have given the prompt and meta prompt to it, and it's giving me an example of poetry. Do you have any suggestions about what prompts I should give? Please put it in the chat. What should I ask it about? I mean, in the past I have asked it like very funny things like asking about Bangalore traffic, or I have asked it about the weather in London, and it has given me some nice poetry. So do you have any suggestions? Quickly comment, and maybe we can take one or two from the users as well. So I'll wait a couple of seconds. Yeah. Do you have any suggestions on what I should ask for the poetry? Meanwhile, as we look, let's say I can ask it, describe Bangalore traffic. Traffic in Bangalore is pretty horrible, and it's the butt of jokes all through. And let's say, let's submit this and see. Oh, so it's generating a poetry, and it's like quite funny one. Oh, Bangalore traffic, a sight to behold. A never-ending stream of cars so bold, bumper to bumper, inching along, honking and sulking, cacophonous song. Yeah, it's actually a pretty funny poem. Um, and yeah, it's actually doing a good job at that. Um, Explain how precipitation works in a storm. So let's pick that from the comments by Rusiraj. Let's see if what it generates. Let me just copy quickly. Oh, actually, does a very good job. Up high in the clouds, the air is cold. Water droplets form a sight to behold. They cling and cluster. They grow and grow until they are too heavy and they must go. What a funny, fantastic poem, actually. And this is like really good, and we'll see a few more examples. But let's quickly. Okay, let's take one last one because this sounds interesting. How is the weather in Mars? Okay, let's see. It does a good job with that. Mars, the red planet, so far away, a barren, cold world where no one can stay. The weather here is harsh, to say the least. Hostile environment where survival is a feast. So anyone who's seen The Martian can actually relate to this. I think none of us have been to Mars, so I think what we have seen through the different rovers that have gone there and via NASA, and what we've seen in Hollywood movies is what we can figure out. But it seems to have done a fairly good job. It mentions that it has carbon dioxide, atmosphere. So not only is it actually saying this is a part of poem, but it also has very good factual information, right? So we'll stop here, and then because we have a bunch of other things to cover as well. So let's go back to the presentation. So again, this was fun, but how do you use it in the real world, right? So good examples are using content generation, call center analytics, generate responses to customer inquiry. So what OpenAI can do, it can actually frame a question, but humans can actually see whether the response is right or not, and then actually say yes. So the humans are always in control. It's not like completely automated to do that. Or if you want to do summarization, maybe like for example, even things like it can be very good at things like many of us who actually invest want to understand the financial statement of listed companies, and it can actually do a fairly good job of that as well. um, it can also, as we saw, that do code generation. We'll see few examples there as well. How it convert natural language to query proprietary data models. You can generate code documentation, as we've seen in Copilot. It can summarize text as well in social media. If you are looking for searching for specific reviews or specific aspects of reviews, now there are complete startups that used to do that, but OpenAI actually can do this like very easy using information discovery and knowledge mining. So let's quickly go on to the next one. So again, like there are multiple model use cases, end-to-end call center analysis. You can classify text, classify sentiment. You can extract entities. You can summarize the text and email generation. So you can create multiple workflows by leveraging multiple parts of the uh, um, uh, of the model. And then you can use hyper personalization using timely summarization of customer queries as well. Business process automation. Let's also look at maybe Copilot. I think I'll quickly run this through example, but I think many of you might have seen this or experiment with this. But this is actually, it's writing Python code and basically telling Copilot to actually generate that, and it actually is able to generate, the code. So we saw, how it does this a little while back. Code generation, but also, as I said, like proprietary code, right? For example, this is what we're doing in Power BI. We are generating DAX expressions with natural language. Typically this would take a lot of time, but what it does is also, as you submit the query, it is also be able to actually tell what is like the text that is generated. So I showed you Wolfram Alpha. Talked about Wolfram Alpha earlier. This is also very similar to that, except that they are interacting and figuring out what is the way to interact. So it can be used very nicely for code generation as well. Another example is Power Platform, which it can basically can um, create apps very easily by using generating the Power FX formula. So people who are not developers are actually also empowered to do this really easily. And then you have the contact center analytics I talked about, right? This is like I said, that end-to-end scenario. So there is call center agent who is talking to the person. There's a telephony server that audio files go to Azure storage. Then you convert speech to text. Then intelligent transcription happens. And then you can, as I said, like, it's not Azure OpenAI is only one of the services, but you can use Azure Cognitive services, for example, speech and OpenAI together. And then you can power them through Power BI Insights to see what are the trends that are happening, and this can be very near real time, right? So in a couple of hours, or you can also pump that data into CRM, so you can get detailed call history, call reasons. So for example, something, let's say, has gone wrong with your payment systems, you can be actually immediately find out, not just through your technical operations, but if there is maybe a failure at maybe a vendor, you can actually, and your customers, or subset of your customers have that issue, you can see and bubble that issue by kind of summarizing and bubbling up these kind of use cases. I think there was a question about how to use in like trade finance, export, import. And a good example is, all of these manifest, port manifest, all of these forms that come in whenever you do import export, the custom duties paid, all of these document can go into what is known as the Azure Form Recognizer. So Azure Forms Recognizer actually takes all of that data, summarizes, gives it, converts that into JSON format, annotates it, and then that goes into Azure's cognitive search. And what you can do is use the OpenAI service to provide a queryable interface to generate natural language queries, right? Like for example, you want to know how many boxes of, maybe say, I don't know, maybe candles, or how many boxes of how many kgs of avocados were transported. You can ask those kind of queries, and the queries and the data can be stored in Cosmos DB, right? So you can actually integrate OpenAI and with Azure functions, and then that any kind of querying that needs to be converted, and that needs to be not just in the form of raw data, but that can also be summarized. That can also be The data can also be got as maybe numerical arrays, or displayed into Power BI. So all of these different use cases can be done using the same kind of data by plugging in different kind of query backends, as we talked about. Um, we are almost at time, so maybe quickly go through some of the other use cases. So here is an example where I'm using the text Da Vinci model. So this is a customer conversation that is there, and you can see that you're asking Azure OpenAI specific instruction. What is the reason for the conversation? How is the customer feeling? How did the agent handle the conversation? And what was the final outcome? Was the problem solved or not? And finally, create a small summary of the conversation. So you can see that the main reason of the conversation was to report a car accident. The customer was shaken. Obviously, I mean, he has been in an accident. He or she has been in an accident, and the agent handled actually well. The agent was empathetic, and the final outcome of the conversation was the agent started a claim and ordered a tow truck. Right. So this is a good outcome, right? So he has helped the customer, and then finally it summarizes in that. um, another example is, take the conversation, and then you can see that it has taken this conversation and converted that into output as JSON. Now this output can be taken and put into, like, say, a Cosmos DB or a MongoDB, or even if it is even more structured, then you can put it in a MySQL or Postgres, and then you can use Power BI to run the analytics, right? So this is a real world example of what we have seen earlier as well. So now the input, what I've done is I made it a little harder. The input is in German, but I'm interacting with the model in English, and the output it is giving to me is in English, right? So what is doing, it doesn't matter what language they inputted, what the output is. I can actually interact with in the language I'm comfortable with, and then convert that into a different. So we talked about um, we talked about this a little earlier, and now this is like in action. So again, right, this is how the I don't know if I'll have enough time to demo, but let me maybe quickly do one demo on Azure OpenAI Playground. So haven't. So we talked about poem generation, about helping assistant, but we have not looked at summarization. So let me just quickly do see if we can get a summarization demo. So this is how the playground looks, and then I have selected selected the DaVinci 03 model. So what I will do is I'll take some text which I have taken from Wikipedia. Let me just type it here, paste it here, and then let me start interacting with this text, right? So it's a lot of text. It also has a lot of, like, jargon. It talks about gravitational collapse. It talks about atomic nuclei. It talks about degeneracy pressure. So I just wanted to maybe, like, summarize the text so that I can understand it a little better in more layman terms. So let me just try this, and let me say generate a response. So this has taken a neutron star, and it's put it in a place that I can easily understand. So they are the smallest and densest known stellar objects, and the radius and the mass, and it's formed after a supernova, and consists mostly of neutrons, which is where I think the name neutron stars comes from. But it still talks about, it has a remnant star, it is collapsed into form a black hole. I want it maybe even more simplified, because maybe I want to explain it to a 2-year old. So let me take that and try changing the prompt. So you can see that it has made it really simple, right? It's not talking to a 5-year-old. Neutron stars are really special stars that are really small and really dense. They can be made when a really big star explodes and the core of the star collapses. They are so small that only about 10 kilometers across, right? So now you can see that it has actually even made it easy without, and it has lost some of the superfluous details that you don't need to answer. I can even go a step further and say, you know what, uh, I understood as a 5-year-old, but can you also? I have some, favorite astrophysicists, and maybe how would he or she would have explained about text, and I can generate the text, and it will tell you, how they would have explained the text, right? So it talks about, how Carl Sagan would have, who is a famous astrophysicist and science communicator, uh, uh, you know. Uh, covered this, when he did one of his TV shows. So at every level you can see that, it's not just how it's summarized, but you can tune the summarization in a way that can make sense to you. So let me go back to the presentation. Cool. So, quickly, in the interest of time, let me also, you've seen bunch of these things on the screen on the left-hand side of the screen, right? So let me quickly see if I can explain that, right? So, you can see there's something called as temperature. The temperature actually controls the randomness, and lowering the temperature means that the model will produce more repetitive and deterministic responses. Max tokens is the amount of tokens that it can generate. So if I want the output to be smaller, I can reduce the number of tokens. The frequency penalty basically um, reduces the chances of a token proportionately and how often it actually shows up in the text. And Similarly, I think top probability controls the randomness but uses a different kind of method. Presence penalty basically reduces the chances of repeating any token that has appeared earlier. So it will make sure that the prediction has somewhat unique, more unique tokens, and increases the likelihood of introducing new topics, and different kinds of things are covered. So, for example, if you want to cover a lot of ground in summarization, then probably you will reduce the uh, presence penalty. And finally, best of responses, basically it can run multiple times, but the only thing that you have to be and then you will kind of select the best and most probabilities response. The thing that you keep in mind in best of is that you can it can the unused candidates can incur costs as well. So with that, let's maybe quickly move on to another demo. This is a canned demo, so which I've recorded.
Hi everyone. Today I want to quickly show you how we are bringing OpenAI's powerful models into the Azure ecosystem to help developers both iterate faster and satisfy their enterprise requirements. Here you can see the Azure OpenAI Studio, which we built to help all skill levels prototype their ideas and bring their creativity to life. With our Studio UI and the flexible models from OpenAI, you can iterate on different use cases with the same models in UI. For example, here I'm going to ask the model to extract information from an email by including both the email and my question written in natural English. Or I'm going to ask the same model to convert a paragraph description of fruits on an imaginary planet into a structured tabular format. In my third example, we'll use the same model again to classify news articles. Finally, we'll use a different model, our Codex models, to generate documentation on the provided Python function but still within the same UI. Once developers progress further in their journey, they can easily transition from this prototyping to fine-tuning and customizing their models all within the UI. Finally, when developers are ready to move towards a production application, they can leverage some of the more unique aspects of the Azure service compared to OpenAI's. We provide key enterprise promises with network security, privacy, and responsible AI tooling. For example, we enable authentication through Azure Active Directory so customers can securely access their fine-tuned models.
Cool. So this is how the you can use the Azure OpenAI Studio to manage different models and try different experiments.
Hi everyone. Today I want to quickly show you how we are bringing OpenAI's powerful.
So let's quickly. So we already went through this. So again, there are top use cases where as you can see on the screen, government agencies, financial services, aircraft companies, consulting services are using to convert natural language to query appropriate data models. There's also international insurance companies that I talked about using Azure OpenAI to summarize financial reporting or provide summaries of call center support. So there are all of these different use cases across a different variety of different, and many times they are kind of chained together and used with other Azure services as well. So there are multiple benefits: increase efficiency and productivity by getting more done in lesser time, and then also if you're a startup, you can rapidly prototype and reduce the time to market, faster time to realize value, absolutely. Enhance customer experiences with greater focus on customer-centric services. So it augments the human, and actually a human can only keep so much context. So it kind of helps humans do a better job. Easy to use, even junior data scientists or business users can use, as we have seen in multiple cases. I talked about the Azure OpenAI Service. It ensures data security and privacy, and you implement it in a responsible model using a trusted cloud provider. Does not require a tedious annotation process. Anybody who has trained models knows how painful this entire process is, just collecting the data. Also, less reading data is required for many relevant use cases. We've seen zero shot learning, few shot learning, and so on. And again, as we've shown, that ability to perform text analytics and generation tasks that are now up till now only reserved for humans. So these are all of the many different clients that customers are using, and maybe in the interest of time, we'll just quickly go to the customer use cases. Some internal ones, like there's a Microsoft Designer, which actually using Dolly to be able to generate images, and then somebody who's building a website and wants specific images can actually generate an image very easily by putting in a description, and then that script can be built. This is great for like non-technical users because it kind of empowers them, and then it's able to either create slideshows or able to design a website and then easily upload it. And as we go ahead, I think these are like I think probably the slide which has a lot of different kind of use cases. We talked about Codex, language, and again, like GPT-3 is part of it, and then Dolly, which does image to text. There's lots of different kinds of use cases that are there. I think one other use case which I've not covered here is the Microsoft launch Copilot for M365 apps as well, and that can help you like reply to emails or collect all of the data across maybe through email chains and summarize it. So again, like it has been used in many different contexts for a variety of use cases. National Netherlands is a customer, and it's the largest player in Dutch insurance, and it is using Azure to extract information from large volumes of unstructured data to handle the claim handling processes. I think somebody has asked a question about how do you use it in banking and insurance. This is one good example. And provides the building blocks to develop AI solutions that can understand Dutch text. Right? This is not even English text. So there are two parts, which is like text translation and text summarization, that are getting used here. This is another interesting applications. Soul Machines. It creates digital people that transform brand experience by creating engaging and emotional connections with the customers. And when I look at something like this, I remember the sci-fi movie Her, which was fantastic, and we're getting closer and closer to that. But again, this is just the beginning. So it increases the empathy of the digital people, so the conversations with the users are more deeper and more meaningful. And it uses it for generating the avatar and producing the copy for conversations as well. Then again, in agri-tech, there is a lot of sentiment analysis done by Farmlands Cooperative, and we talked about different kinds of model, right? They're using Da Vinci and Curie to highlight current trending key phrases and prepare summaries, so that the business users can drill down and look at these case and interactions summaries. Right? So it saves call center staff time and improves customer experience. And in terms of generating content, it's a game changer, and we've seen few examples of that as well. Another example is CarMax. So CarMax has basically helps customers actually select cars, and it has produced years worth of car summaries in a matter of months. I don't know if this was even humanly possible, but and if it was possible, it would have taken a lot of time and money. But a lot of automation can be done using that. Then there's another startup called Trellent, and Talent is a pre-seed documentation, code documentation startup that uses the Codex algorithm, which we saw as well. And how it basically enables small enterprise teams to be able to provide service. And we did a MFS webinar, and they were able to use it with Azure security safety controls, and also global availability to be able to take the content, filter it, increase security, and then it could be used by different customers as well. So I think I will leave the resources on the screen. Just give me a second. But if there are any last couple of questions, we can maybe take those questions as well. Okay, let me just hop over to the questions. If you have any questions, please put them in the chat, and we will take a few questions. We are a little over time, so we won't be able to take many questions, but happy to take any questions as well. What is the best platform way to learn this concept in detail? By Siva Bonagiri. I think the best is, like I said, like look at the Azure OpenAI docs, look at the OpenAI docs, experiment with the playground. If you want to especially use GPT-4, I think there's a fantastic paper which is there up on screen, which explores a lot of different use cases with GPT-4. GPT-4 can actually do a good job with medical data and legal data, and it can also maybe be used as a basis. While it is not great at image generation, it is great at instruction following. So it can generate a template, and that template can be fed into like stable diffusion or other kind of use cases to increase the fidelity of the response. So you can actually use OpenAI to actually chain different kind of responses as well. So I think the best way to is to read the documentation and play, because so much of it is new that you won't find any tutorials, webinars. You constantly have to implement and try out different stuff. And for further learning, I think Parth has put some of the links in the chat, and he'll put them in the screen as well. So you can go to aka.ms, explore Azure-OpenAI, which can be helped. So Akshay Shah is asking, Chabit GPT-4 is $20 per user. That is actually the a personal version. Yes, that can be. So there's something called ChatGPT Plus that you can use, and it gives you faster response times, and it gives you better interactivity for question for any kind of interaction as well. Sunny Bhatia also, I think, asked a similar question. How can I learn this quickly? Yes, I think I already answered that. You know, you can go to the docs on the screen, and I think there is also link AKMS/explore AI. That is probably the best way to answer. Satya asked for Bangalore traffic as a sonnet, and you saw how it generated a funny, funny quote. I'll put it on the screen as well. Uh, yeah, so if you want to take a look at it again, it's quite funny. Yeah, and it tells you, like, anybody who's in Bangalore and stuck in traffic can have a laugh, but also wince in pain while reading this kind of sonnet as well. Danish Ahmad Siddiqui asks, how do you integrate this model, the GPT-3 and Dolly in applications? Again, I talked about the APIs. So you sign up, get the subscription API, and then it is super easy to kind of interact with the API, typically as you would interact with any kind of web API. I think probably we'll do maybe a longer session, but I think the important thing here is to figure out how do you do the prompt engineering and fine tuning. But because it's like more of a 101 201 kind of a course, I think it's out of scope. And you can integrate in Python, you can integrate in different languages. Again, it's a REST APIs. Anything that support REST, you can actually integrate in the application really easily, and give it context. GPT-4 can also generate a lot more tokens as compared to, I think it's 32,000 tokens, and GPT 3.5 is, I think, 4,000 tokens, if I remember right. So GPT-4 was also multimodal, so it can generate images as well. Though it is still not as good as maybe something like Stable Diffusion or Dolly, but it does a fairly decent job of GPT-4. So once you interact with GPT-4, I think you can go on the website and ask for access. As well, it's a waste. Akshay Shah says GPT-4 API is not released. It is actually released on Azure OpenAI, but I think on the OpenAI website, it's on the it's waitlisted, right? So you can go on the wait list. There was one more question actually. So I think with that, are there any last questions? Wait for a moment. If there are any final questions. Cool. So I think, if so, any, so I think quickly, all the key takeaways would be, I think you go to the documentation and use the playground as I showed. Also, read these papers and experiment with the format. That's the best way to learn. And pricing, I think, Shiva, you're asking about the pricing. The pricing is there on OpenAI. So AKMS/OAI/pricing, it will take you to the pricing page. And you can look at the price, so how we can integrate. Similarly, I think the other takeaway I would say is, different use cases as well as the different kinds of model that can use. So all of this, OpenAI is actually running on completely on Azure infrastructure as well. And again, you have access to other Azure services as well to integrate it if you want, maybe text to speech, speech to text, or do information extraction from handwriting based models. Those kind of things also, you can use the cognitive services as well. Cool. With that, so you can see my handle at Vinayak H on Twitter. So if you have any further questions, you can ping me on Twitter, or you can go to the also go to the AKMS/explore Azure OpenAI link as well to kind of learn a little more. Further down in time, as GPT-4 also gets usage and we play around with it a little bit, we'll also be having a little more advanced webinar on maybe prompt engineering as well. As well as the data model as well. So keep an eye out, and you can also subscribe to this series. So the series page should also be up on the screen in a bit.
Thank you, Vinayak. Thank you for a wonderful session. Hope you all enjoyed it. Let's call for a wrap.
Cool. Thanks everyone.
Thank you, everyone.
And hope to see you in the next edition. Bye.